Hello student, now I'm going to start one concept which is application based. So student, what is the name of concept? Hydro hydrostatic hydrostatic paradox. Okay, so student, there is particular conditions to apply this concept, right? So this concept applicable to students, this concept applicable only for in a uniform fluid, right? So students, you can say what is the meaning of uniform fluid. So this is students, you can say like synonyms of uniform fluid: same nature of fluid. What, my dear? Same nature of fluid, right? Okay. uh, if nature of fluid remains the same in a uniform fluid, what you can conclude, students? Pressure is pressure is what? Independent of. Students, this point I'll cover over here. In a uniform fluid, student, pressure is independent of. There are following points. So student, this is point A: amount of the liquid. What, my dear? Amount of the liquid. Now point number B, student: shape of the container. Shape of the container. So these are the basic points to apply hydrostatic paradox, right? So students, if these 2 points satisfy, then what you can say? So if a given liquid is filled in a vessel of different shape, if these points are satisfying, students, then we can say if you will fill same amount of liquid in a different vessel, then what you can conclude? Pressure at the base in each vessel will be same. Why? Because if you remember, pressures due to liquid on the base of container depends on only what? Density and what? Height or depth of the liquid filled in the container, right? So these are the points, students. For better way to understand this one, students, here I'm going to consider there is a what? Example, so that you can easily understand. So now students, for this condition, let us suppose I'm considering there are 3 different shape. So this is, students, first one, this is conical shape, right? This is, students, conical shape. Now students, second one I'm considering, this is a cylindrical shape. This is what, my dear? Cylindrical shape. Okay. Now students, I can say third one, this is the trapezium. This is the trapezium, right? Okay. This is conical, students. This is cylindrical, and this is trapezium. This is what? Trapezium. Okay, fine. Now students, here I'm according to this condition, because I wanted to apply this concept over here. So I'll fill, because base remains same base area I'm considering over here. So I'll fill liquid remains same. Liquid remains the same everywhere, right? Okay, students, here I wanted to just little increase the size of this container. So now we can take this is the basically container, same liquid level, right my dear? Okay, so what you can conclude over here, students, you can call it conical. I'm just calling A. This is shape of B, and this is what? Shape of C. You can see here, this is point A, my dear. This is point B. This is point C. So what you can conclude here, students, because these are different shape of container satisfying a paradox principle. So what's a hydrostatic principle? Uniform fluid, correct? Semi-zero fluid. Next is what? Amount of liquid remains, because it's independent on pressure. Shape of the container, it's independent, students. So what you can conclude? What you can conclude, my dear? Pressure at A is equals to pressure at B and pressure at C. Right, student, there is different points we can also conclude. In which container masses is more? So you can say this container, this is MC, then what? M2 means MAB, student. Then you can say what? MA, it's a very less. So now students, here you can say in which has a more weight. So what you can say? Weight of C, then weight of B, then what, student? Weight of A. So this is the first example which I gave you. Now students, next example I wanted to again I wanted to take one more example to clarify more. Student, take snapshot. I wanted to turn the page. I hope you have already taken. Now students, have a look. Next example. So what's example, student, for next? For this condition, students, note down one question please. So this is a question, student. Equal volumes of liquid, equal volume of liquid visible as visible are poured in 3 vessels A, B and C. All the vessels, student, all the vessels have a same base area. It's an advanced question, students. More than one option is correct, right? Select the correct alternatives. Select the correct alternatives, means you can see more than one option is correct, students. So now diagram is, students, mentioned over here, right? So this is diagram 1, or you can say this is diagram A. Now students, this is diagram B. Now students, this is diagram C. Okay, diagram A, B, this is what my dear, C only, right? So there is option students. What's option first? The force on the vessel will weigh maximum in vessel A. Option B is student. The force on the vessel will weigh maximum in vessel C. C student, what's the C option? Net force exerted by liquid in all three vessels is equal. Last option student, options number D. Net force exerted by liquid in vessel A is maximum. Now, this question basically, right? Have a look at the question. Now, just have a look. Student further. I'm going to explain this question. What's the question? Do an underline. Equal volumes. So what you can say? Height everywhere remains same. And what's the next point? Same base area. Okay, these 2 points we have. So students, equal volume, again you can feel the same thing, student. Right, student? Okay. So students, in which has a more force. What's it? The force on the waist. Force on the waist will be maximum in vessel A. Not at all. Why? Because there is what, student? Side wall. Side wall, no, normal. If you remember lecture 1 or 2, when I was explaining pressure concept, students, for that condition, liquid always applying force perpendicular or normal to surfaces, right? So students, you can say for this condition student, what is the point which you can conclude as equal volumes of the liquid is filled in all vessels, right? In case of vessel C, pressure at the bottom is more than the weight of the liquid due to downward force exerted by the side wall, right student? Because here side wall force will more, with respect to these all two cases, due to this student, what you can say, force on the vase will be maximum in vessel C. Why? Because students, there is a what in the vessel C, pressure at the bottom is more than the weight of the liquid due to downward force exerted due to what? Side wall. Due to what, my dear? Side wall. Due to this, what you can say? Force on the vessel will be maximum in vessel C. So students, options B is correct. Options B is correct. Now, what's the next? Net force exerted by liquid in all three vessels equal. Correct only. Why? Because what is net force? Same base area, na? But what's the pressure everywhere? Rho gh. What you can write? Rho gh. So what's the pressure? Force into area. So we can say net force exerted by liquid in all three vessels is what? Equal. Students, this is all about hydrostatic paradox. I'll see you in the next class.